Hello, everyone, and welcome to the Independent Sage briefing. Well, we're now years into this pandemic, but today we're taking a bit of a pause to examine the origins of SARS-CoV-2. While many of us have returned to some form of normality, it's still important to understand the origins of this virus because it will help us to deal better and be prepared for any future pandemics. Throughout these 2 years, several theories have been floated as to the origins of COVID-19. But what does the evidence really point to? And how much scientific weight should we give to these different theories? Well, today we're going to get you the best of what science can tell us so far. But before we move on to the session, as always, we'll be having our numbers segment. And I'd like to invite Dr. Duncan Robertson to present the latest COVID trends to us. Over to you, Duncan.
Thank you very much. So we're at the situation where we have infections, and these are from the ONS survey. They're falling. We're having hospital admissions are going down, but are starting to potentially level off. We have new variants, BQ1 and BQ1.1 are over half of the sequences. And we have good take-up of the autumn 2022 booster in older eligible age groups, but not quite so good in younger eligible age groups. So just to put that in perspective, these are infections, as I say, from the ONS survey. That's a representative sample of people from across the countries of the UK. And in all constituent countries, the prevalence is falling. So this is a good thing. So this is kind of coming out of the BA4 and BA5 waves. So that is a good thing. But we can see in the latest data we have, it tends to be older people have a higher prevalence than younger people. So how does that feed through into pressure in hospitals? Well, we are seeing a fall in hospital admissions. So this is daily hospital admissions is going potentially down to another minimum. Of course, you can't see what's going to happen in the future, but it's starting to level off. And we can see when we split that down into age groups as well, we can see that there's potential of each of those age groups starting to slow down the rate of decline. So we need to kind of wait to see what's going to happen in the future. In terms of as well as the number of people going into hospital, we can look at the number of occupied beds in England, and that is falling too, which is a good sign. And looking at splitting it to people who are primarily being treated for COVID and being treated with COVID, we can see they are both kind of falling in step with one another. And then probably the most serious patients may be in mechanically ventilated beds, and that too is falling, which is a good thing. So we don't know what's going to happen in the future, but certainly we're it's more positive than it has been in the past. So looking at deaths, we can see that potentially we're past the peak of the BA4 and BA5 wave. But of course, there's more data to come, and we're never, fully up to date with this until all the registrations had been done. And this is the data for Scotland, Wales, and Northern Ireland. And so it's really to say there are still deaths occurring from COVID in all countries. And then if you look at a more crude metric, but more up-to-date metric, this is daily deaths within 28 days of a positive test. So this is before you've potentially got a death certificate. So that too is falling. So good news. So as well as COVID, if you look at the pressures that are on the population, we have other respiratory diseases. So this is looking at what's happening with influenza in the UK. So we have these dotted lines, which are previous years, and we have these bars, which is this current year. And we can see potentially we're at or just coming past the peak of this current year. There's still quite a lot to come. But you can see this solid line here is what's called the positivity, so the percentage of tests that come back positive for influenza, and hopefully that's reached a peak. And as well as that, we also have other respiratory, and this is splitting it down by year groups for influenza. And as well as that, we also have other respiratory viruses as well, and these come and go in peaks as well. So as well as COVID, you've got influenza, you've got RSV, and other viruses that all put pressure on the health system. Of course, we've had unseasonably mild weather. The question is what happens going forward when it becomes colder and more people potentially congregate indoors. So what can we do about that? Well, we can look at vaccination, and generally in terms of the autumn 22 booster campaign, relatively good percentage of coverage of eligible people. This is over 65s, and you can see Scotland kind of doing the best, followed by England, then Northern Ireland and Wales. So still there's some variation between constituent countries, and there is more to go in terms of people fully getting their vaccinations. And this, I think, is potentially a bit of an issue in terms of 50 to 64-year-olds. There's still a long way to go in terms of getting all of that population vaccinated. So as you'll be aware, that over 50s are eligible for vaccination but by age, as well as younger people who may be due to vulnerabilities. So I think one thing is the over 50s, so up to working age people, for example, over 50, there's still a range of people to be able to get vaccinated there. And we can see that in this chart. This is from UKHSA. So looking at this booster campaign of over 50s, and you can see the older people just tend to be very well vaccinated. And these lower lines, the lower line there is 50 to 54, and we can see relatively low numbers of people in that age group have been vaccinated. So, with all these things, come forward for your COVID vaccination, but also flu vaccination to protect you over the winter. And this is vaccination coverage for over 75s, and we can see very good coverage of for the autumn booster in brown, and then previous vaccination campaigns in other colours, and only very few people who haven't been vaccinated at all. And as you go down the years, we start to see more people not vaccinated, and then so as you go down the years, fewer people have had their most recent vaccination. And then, of course, if you go below 50, where you don't get vaccination in this autumn 2022 booster as of right, we can see that there are still significant numbers of people that are not vaccinated at all, particularly for younger children. And just very quickly on variants, this is from UKHSA looking at the history of variants, and we can see that we're starting to go into this BQ1 and BQ 1.1, which is this brown line here. And potentially we have over 50% of sequences that are either BQ1 or BQ 1.1. So that, if you like, is the latest wave of variants. So to summarise, we have infections falling, hospital admissions are levelling off. We have BQ1 and BQ 1.1 are starting to become dominant, and we have low take-up of that autumn 22 booster in over 50s, but younger over 50s. So thank you very much, and I'll pass back.
Great. Thanks so much, Duncan. Well, as I mentioned previously, we are going to discuss the origins of SARS-CoV-2 today, and we're delighted to welcome two guests who have joined us for that, and that's Professor David Robertson and Professor Stuart Neal. So I'd like to ask Dr. Steve Griffin and Professor Aris Katzourakis to introduce our guests and to kick off the session. Over to you, Steve and Aris.
Thanks very much, Martin, and welcome everybody, and a special welcome to our guests, David and Stuart, for joining us, because we really are lucky to have two real experts in this area that we're talking about today. And it's worth remembering that this pandemic is incredibly unusual. Some people have called it a once-in-a-century event, but the reality is that we are constantly being bombarded with the opportunities of viruses to cross over from animal species into humans. And we're probably not aware of this, but Even at the moment, we have virtually all of our domestic poultry inside because there's a massive infestation of H5N1, highly pathogenic avian influenza. And there are other outbreaks across the planet, such as Ebola, Marburg, Nipah, you name it, it's coming. So it really is sometimes only a matter of time and chance before an event like this, not quite once in a century, but close enough, can happen. And unfortunately, as the human race expands its habitat and we affect climate change and we increasingly interfere with natural habitations, we're unfortunately going to see this happen more and more. So back in 2019, when we saw the first emergence of SARS coronavirus 2, everybody was in a state of consternation. This was a massively important event. And of course, it's caused untold damage, more than 20 million dead projected, trillions of dollars of cost. And so it's right to ask the question, where did this come from? How did it happen? And it perhaps wasn't helpful that at the start we didn't get all the news that we may have done from the Chinese, but that doesn't necessarily mean that there is anything really to cover up. The city, Wuhan, where the virus emerged, does indeed have a level 4, biological safety level 4 laboratory where these sorts of viruses were played with. But that doesn't necessarily mean there's something going on. And unfortunately, when the questions started, they were incredibly legitimate, and they've gone from, frankly, the bizarre to the ridiculous. And the conspiracy does rage on, but we now have a really good in-depth knowledge of some of the initial events that probably contributed to how this virus jumped into humans. And in actual fact, we now know more probably about SARS coronavirus 2 than many viruses that we've come to understand across this planet. So I'm now going to just hand over to Aris, who's going to start talking to David and Stuart about what may have happened in terms of our scientific understanding of the virus and where we're at really in terms of understanding how to prevent this and its impact on research going forward. Over to you, Aris.
Yeah, so in sort of early 2020, we were talking about this novel coronavirus. We didn't have a name for it for quite some time, and it sort of seemed to appear out of nowhere. But we now have a much better understanding of its history and its emergence. So, it's a coronavirus, and so what do we know now about how this particular lineage SARS-CoV-2 is related to other coronaviruses? So addressing this to David Robertson first.
So I think what was very clear even early on was this was SARS-like virus, and so what happened was a relatively divergent lineage. I think it was about 25% divergent, so a number of mutations. So the first SARS virus had emerged, and we know that the first SARS virus is related to horseshoe bat. So I've got a figure. We have the figure to show what we. I think this figure shows very nicely what we know now. Do we have that tree? And can everybody see that big? It's very small. Yeah. So the representation here is essentially looking at evolutionary history. And so based on relative numbers of mutations, we can infer common ancestry. And so almost none of these viruses were available to us prior to 2019. And what's really important to appreciate is that there's a lot of recombination going on. So these viruses are mixing up. And so this is just an inference on one part of the genome. And what's happened really is that across a lot of China and into Southeast Asia, you have viruses co-circulating that are related to SARS-CoV-2. And when the virus first emerged, we just didn't know that. It looked very different to anything seen before. In particular interest was the part that bound to ACE2 looked unique, but very quickly there was a virus from a pangolin that was closer. There's now viruses from Laos that are almost identical to that important region of the virus genome. And so what's really clear is that there are naturally circulating viruses that are highly related to SARS-CoV-2 circulating in nature, and that we didn't know about any of that diversity before 2019, and that's just a sampling issue, And although there have been restrictions on the Chinese researchers sharing data, there has been a steady sort of trickle of viruses that have been released, and so it seemed very clear that that this is a very ancient viral lineage that has this interesting property of being able to jump to other animal species, and so it's not particularly adapted to humans, and it can infect mink. It's already in deer naturally in the US. So it's quite an unusual virus. We kind of expect novel viruses to have to accommodate to their new host and evolve, whereas here you've had this, what you might say, ready-to-go virus, and that links a lot to this furin cleavage site. So I don't know if, Stuart, do you want to talk about the furin cleavage site? That's your expertise.
Yes, I can do. Do you want me to talk about that now?
I thought we just...
Yeah, okay. So just springing off what David was talking about, the spike protein of SARS-CoV-2 is really the most important protein of the virus when we're considering its ability to infect different species and infect humans. And there are two real parts of the spike protein that are important. There's this receptor binding domain of the protein, which binds to the cellular receptor that's called ACE2. That allows the virus to lock onto cells and infect them. And then you have what's called this furin cleavage site. So if you imagine the protein being a spike, about halfway down that spike is a cleavage site. And as an intrinsic part of the virus getting into the cell, that site has to be cut open. Now, what's intriguing about SARS-CoV-2, which is different from every other member of the related bat coronavirus family that we're talking about, that we know thus far, is that it has a cleavage site that can be cleaved by a protein called furin on the way out of the cell. And what that has endowed the virus with is a much better transmission advantage between mammals by the aerosol route. And we see furin cleavage sites in many other more diverse coronaviruses in mammals and in humans, and we see them in other respiratory viruses as well. And they're very important for viral transmission between individuals. So a key contentious question is where that furin cleavage site has come from, because it is in effect a 4 amino acid insertion into that viral protein. When you don't see, in fact, actually, I think I'm right in saying that in all known bat coronaviruses, irrespective of whether they're related to SARS-CoV-2 or not, I don't think there is a known furin cleavage site at that position. However, we do know now that certain more distantly related members of the family of SARS-CoV-2 do have sequences at the boundary which are about 1 amino acid away from a furin cleavage site. So,
I mean, that's in the figure. If we want to show that again, there's a nice visualization of that might be helpful.
Yeah. So I think the idea is, and certainly the hypothesis at the moment, until we find one in a bat, is that these furin cleavage sites may have more of a transmission advantage outside the bat than inside the bat. It's in all likelihood that has evolved during a skip from the bat into some intermediary species. And that's one of the key upstream questions that we don't understand at the moment.
And it's important to emphasize it's quite a sort of lowly constrained region. So in that alignment on the right, in that virus there, RMYN02, there are amino acids appearing at that site. So although they're not actively promoting this functional property, there's mutations accumulating there. It's just convergent evolution, as we're very used to seeing with SARS-CoV-2. These viruses are very able to lose and acquire functions as they get into new hosts. So the important thing, there's nothing suspicious about this. It's exactly what you'd expect from a natural virus. There's just no need to invoke any special circumstances or human intervention. And even if there was human intervention, you wouldn't do it this way. It's just a suboptimal furin cleavage site. It's not something a designer would do. I mean, don't you agree, Stuart? It's just.
Well, I would spring in on that and say that this is one of the key sort of areas of the lab leak hypothesis is that because this site has not been seen in other closely related viruses, then it may have been man-made. Now, that really doesn't hold any water when you look at the genetics of this. So it's a 4 amino acids insertion, yes, but that 4 amino acids is actually out of frame, or that 4 amino acid, what the insertion that's generated that 4 amino acids is actually a nucleotide sequence out of frame, which, you know, no one would design normally. I mean, you just wouldn't think about it really. And secondly, one of those amino acids is a proline, which you wouldn't put in that site anyway, because a proline is a rather mercurial amino acid to put in. It can very much change the structure in unpredictable ways, so you just wouldn't design it that way. And thirdly, if you were going to put a furin cleavage site into that yourself as a design to see what would happen, you would use a very well characterized, very efficient furin cleavage site, and not one that is not particularly well predicted by the prediction engines that you can run amino acid sequences through to see if there is a potential furin cleavage site there, if people understand what I'm saying.
And you wouldn't fit into a virus you've never seen before. That's the other part, that this virus is novel. It's exactly what novelty means. You can't do experiments on viruses that you don't have. I mean, there are some viruses that the labs had, but they are thousands of nucleotides different. And so you can't take a virus and manipulate it to become something else without knowing what that target is. It's just crazy. And so very much, you know, between the viruses we've observed in nature and our understanding of the genome structure, the genetics, everything here is entirely consistent with the natural virus. So a virus that's been circulating, was previously poorly sampled and frighteningly over a very large geographical area. So these viruses are circulating right down into Southeast Asia. And so we do need to surveil for these, I think, in earnest and understand better future risks. Yeah.
I think it's also important to stress what David was talking about earlier, which is that these viruses are all co-circulating in the Southeast Asian bat species. And in doing so, they are infecting the same hosts and thus having the opportunity to swap bits of their genome. And the replication strategy of these viruses really does foster that as a means of genomic diversity. So,
I mean, to sort of add to that, the bat viruses are undergoing what we might call antigenic shift events. So you see a hotspot for that recombination over the spike. Yeah. So unlike what's happening in humans, where you have incremental evolution to escape immunity, the bats are swapping these spikes. And so the virus is essentially making large jumps to evade host immunity. And then that's the danger with another SARS spillover, is we're now part of that range. And so a divergent spike might emerge that has, you know, immune evading properties. Although nothing, I think, will outcompete Omicron at the moment. Yeah.
But also in terms of what I mean, much of this work is actually David's groups in collaboration with others is that this recombinant natural history of these viruses means that it's going to be very, very difficult to go into nature and find the exact precursor of SARS-CoV-2. But what we are going to find is bits of SARS-CoV-2 within the family. And that's exactly what we found with the receptor binding domain of the virus, where it was novel when it was first turned up in SARS-CoV-2, but now we have two independent related viruses that have essentially near as damn it that same RBD, one from a bat in Laos and one from a pangolin.
Yeah. And so some of those bits are actually remarkably similar, right? Like we don't have a precursor virus that is almost identical to SARS-CoV-2, but in some of those recombinant segments, we're talking about incredibly high degrees of similarity to the virus in humans, right?
Yeah, and most importantly, functionally identical, doing the same kinds of things. And that's the bit that changed. So in early 2020, you had a new virus, nothing like it, and you had a few that were more similar. But since then, we've got lots of these, and that picture has really been filled in when you have.
Could you say a few words about the?
Sorry.
about the very early genetics. Like, so I mean, initially there was a strong assumption that we're talking about a single transmission into humans, but the genetics are starting to paint a rather more complicated picture about how many times there have been jumps between species.
Because there was initially, or there's always been two lineages that were co-circulating, and they were named A and B, and they were separated only by a couple of mutations. But what seems clear now is that actually sort of that they're very likely to be independent spillovers. And so I haven't, do you want to look at the next slide, the one we had on the Hunan market? Because I think the sort of the other piece of evidence that's very compelling, is so we've discounted that it's a man-made or human-created virus, and so then is it just an accident? Is it an accidental leak? And there's no evidence for that, nothing. But what there is evidence for is a very strong association with the Hunan market. And so both those lineage A's and B's are sampled from close to the market. But what's really compelling is and that's what this is on the right is showing, is that this market was identified because of the first people that were getting sick. And I think what we forget looking back is that we didn't appreciate how many mild and asymptomatic infections were occurring. And so when these people were turning up in hospital, it wasn't clear that they were, why they all had this pneumonia. There was no obvious linkage between them. And so it took a week or so for the Chinese hospitals to appreciate that a large proportion of them were associated with the Hunan market. And there was an ongoing puzzle about, well, why only some, not all? But, again, we know that now. We know that actually that's not at all surprising because so many cases were mild. So you're losing the linkage essentially between the cases. And then what's really, if you look in the bottom right of this figure, so the people that weren't epidemiologically linked, so no recorded history of being at the market, all live close to the market. So those unlinked cases cluster statistically around the Hunan market. So you've got this very compelling evidence of the first linking to the market through the actual reporting, that human conversation about where do you think you might have been recently and connecting it to an animal market. But also those unlinked cases based on home addresses. And so this is now just like the first SARS virus, nothing particularly surprising. This kind of viruses, we know it can get into raccoon dogs, the kind of animals that we know are for sale in this market, and that's been confirmed. And so the evidence is just very compelling that the Hunan market is the location. And then the Chinese CDC actually did environmental sampling. So they sampled from various locations in that market, and that's the bottom left figure. And so these environmental samples are testing positive in the parts of the market where you have live animals for sale, and even from things like feather machine, from the kinds of places you would expect animals to be infected. And the most incredible thing is Eddie Holmes actually took a picture of one of these spots and in a visit there 5 years ago. And so it's just, this whole story is just very much honing in on this one market. And in terms of labs and leaks, there's just nothing. More and more complicated conspiracies that are being brought to bear on this. But here you have this very strong evidence that the viruses related to SARS-CoV-2 are circulating in the animals. And there is a missing link, and that's the intermediate species, the actual species. But this is a very difficult kind of data set to deal with. And so, you don't expect to get all the pieces. But in terms of understanding a spillover, it doesn't get much better than this. There's always going to be some gaps. And because of the politicization of this, we'll probably maybe never know much more than this. But in terms of data and the science, it's really there's it's very, very clear what happened. It's a natural virus, very like the first SARS virus. Yeah.
I mean, it's worth sort of comparing the difference between SARS-1 and SARS-2, the spillover in 2003 versus 2019, and essentially there's only one point of difference. The earliest cases are associated with wet markets. They're associated with people who are buying animals or associated with the trade in animals. and people shopping in those markets. There is evidence of more than one spillover from an animal source to a human. And the only difference being is that in 2003, we didn't know about that. And by the time the information came through that was tracing it back to the market, animals were still on sale that could be sampled and were virus positive. We know very clearly now from very well documented sources that one market was selling live susceptible species that could be infected with viruses like SARS-CoV-2, including raccoon dogs and bamboo rats. Those animals were on sale at least at the beginning of December 2019, when we presume the earliest cases started arising. But when that market got closed down, all of that was cleared out and has gone to ground. Many of the traders are not traceable. A lot of the farms have been serving that market have been closed as well. So there's been some excellent investigative journalism on this by a guy called Michael Standard, documenting all of this. So essentially, we have got this black box now of not having the animal, and that's a criticism that you'll hear a lot of people who favour a lab leak saying, oh, we haven't got the animal. We're never going to get the animal because the animals have all been gone, they've all been killed, they've all been disposed of. And the reason for that is that wet markets are a much greater known risk. People knew that maybe they should probably be getting into trouble if they were found with infected animals. So everything's been cleared out. And some of that will have been from a public health measure. Some of that will be people not wanting to get into trouble. But the upshot of that is that that's the big black box we have. And that's the only real difference between SARS-1 and SARS-2.
And SARS-1 is very unusual in having that knowledge. Like for most viruses, MERS, we know it's camels often for MERS, but nobody knows which camel. And HIV, we know there's a lot to do with primates, but you don't ever have the exact spillover. You have an
we've never found a bat infected with Ebola virus.
And what's subtle here is this is a very transient intermediate species, because the viruses circulating in bats can infect humans directly and other species. And something we knew before the pandemic, in fact. And so the intermediate species it really could be quite transient. And so that's something that gets missed as well. It's not like MERS where the virus is actually established in camels for quite a long time.
So I think the evidence for the market rests on three pillars, as David said. It's the spatial localization of the earliest cases, and those are before there was any bias put into the reporting. So the data set is incomplete. That's completely unavoidable. But even so, those cases are statistically significantly associated with the market. Now, if you went later on into January and looked at the cases, they'd be more associated with where most people in Wuhan live. But at the very earliest stage, they are associated with that market.
And it's important, this is all data that was released as part of the WHO's Origins investigation. And so we should really credit those people for doing that investigation. And unfortunately, because of the politicization around the topic, there was no follow-up. That was always meant to be a first visit. And lots of Chinese scientists have contributed to this. And so in some sense, there's some guilt here on the part of us because we've not been able to include the Chinese authors. We've not been able to really work with them on this. And so that's very unfortunate, but it's such an important topic. The data had to be explored and published.
That's true. But it's fair to say, guys, isn't it, that the response from the Chinese this time around was far more open than for the first SARS outbreak?
I think initially, absolutely. Yeah, I think it was when it became politicized, they clearly then just, they maybe been a bit miffed that the Origins report was so badly received, but then they've just, and whether it's just really just they've not wanted to take any responsibility for this, because when people started looking to blame others. But now the conspiracy is so crazy, it's American labs were funded to help. The conspiracy theories are so complicated, and Stuart had a lot of patience with talking to people on Twitter, trying to turn them And, it was fantastic to observe, and he did win. I think a few people did change their minds and have changed their minds. It's like a belief system. People are invested in this, and social media influencers, people have written books, and I think once you're financially invested in something, it's hard to maybe see the science. But it's a massive problem for science, because we don't deal well with misinformation, because it's hard to how do you, because I think something really important here is this idea that there's debate, and there's science on one side, and then there's just nonsense on the other. And there was a recent preprint that got a lot of attention, and an undergraduate wouldn't get away with the quality of work that was put out into the public domain, but nobody can assess it before it's in the public domain. It wasn't reviewed. And, would you agree, Stuart? How bad was that? We shouldn't even
that was an interesting case in point. So that was a paper that had been put together by let's just say non-experts in the field, who started gazing at the sequence and decided that because of certain features in that sequence, it looked like it had been engineered. But if you look at the natural history of these viruses, you look at the conserved sequences they were talking about, you factor in David's research showing how recombinant viruses can arise, and you include all the viruses rather than the cherry-picked ones these guys put in their paper, you now have a complete natural explanation for all the features in the genome of that virus, and you don't need to invoke any engineering. And that's called Occam's razor, folks.
Yeah, it's fair to say, isn't it, that nature is a far better genetic engineer than any of us. And it's very clear that the capacity for these viruses are immense for the changeability and the ability to infect other species. And it really is probably only a matter of time before we see SARS coronavirus 3. Would you agree, guys?
Well, I think Omicron is so well adapted. I mean, Omicron is a monster. It's adapted to humans. It's everywhere. It's still evolving. It would be hard for a virus to emerge and outcompete it, but we could be part of that range of bats now. And so because of the recombination, Omicron could pick up a piece of a virus, from a bat or from deer in the US, or the beta was just, the South African variant from late 2020 has just been found in Kenya. It can be combined with this. And so we're in a very dynamic situation in terms of the evolvability of this virus. It's not finished with humans. And this sort of, when we think about preparedness and SARS-3, that's exactly the right kind of question. It's probably more probable that Omicron will go somewhere unusual than a new thing will emerge. And so we really have to get better at that risk assessment. I think we're currently pushing very hard to normalize this, and this is a new human virus. It's circulating in a lot of people. It's changing a lot. It's getting into animals. I think it's all the chances are Omicron will just slowly, incrementally evolve from here. But our job is to worry about SARS-3. What's going to happen next, and I think that's a very open space. I wouldn't.
So there's lots of lessons, really, isn't there? I mean, we need to maintain our surveillance. We need to maintain our vigilance. We need to maintain testing capacities, and we also need to avoid the sort of trappings that shall we say, certain former US presidents may have leveled at people. Just blaming wet markets, for example. We know that there are risks involved with all sorts of human activities, agriculture, wild birds and domestic fowl. We see these risks all the time: Ebola, Nipah, flu, coronaviruses. The fact is that we need to be aware that we need to consider viruses as a whole in the entire of the world and planet, not just us. And as you rightly say, David, just trying to move on and ignore this, and the chances of something else happening very soon can be very, very damaging indeed.
I mean, it's worth pointing out the scale of some of even the wild, certain live animal sales in Southeast Asia is a multi-million billion-dollar industry.
Yeah.
A lot of it goes on under the counter. A lot of it is black market, or at least turned a blind eye to. a very recent paper that came out by Chinese authors. In fact, they got into a bit of trouble for this in collaboration with Eddie Holmes, sampled live animals on sale all over China and sampled about 2,000 animals. 10% of them were carrying mammalian tropic pandemic potential viruses, some of which more than half of them were unknown to science beforehand. And there were evidence of animals carrying viruses that had only ever been seen in bats, animals that were carrying viruses that had only ever been seen in humans. And these were animals that were being sold and butchered in fairly poorly sanitized conditions. So these sort of techniques and a ticking time bomb for these things, and we must get a handle of working with everybody to try and make these practices, which are often cultural and can't be just got away with straight away, make them much safer.
So just the last point then, guys, just before we move on to the public questions, some of the ramifications around the speculation and conjecture and this kind of false equivalence between conspiracy and actual evidence-based studies is actually starting to become slightly damaging in terms of our ability to deal with this in the future, isn't it? Because we're starting to see hit jobs on scientists doing research, widespread criticisms of what people don't really understand, which is gain of function research, and there seems to be, again, this politicization of the sort of research that will prepare us for this sort of outbreak in the future. I just wondered if you guys had some comments on what's happening and probably what should happen.
I mean, it's deeply unhelpful because we really need to sort of divorce this idea of the origins of SARS-CoV-2 away from a lot of the arguments going on about what is or is not risky virus research. I preface this by saying, I mean, and I can probably speak for David and Steve and Aris here, is I don't think we've ever met a virologist who doesn't care about lab safety. And I don't think we would ever ourselves countenance it or ever think that, any of our colleagues do. We work as safely as we possibly can within the law, and we are always trying to improve the safety of the experiments we do. That being said, there are plenty of experimental systems and techniques that one needs to be very, very careful with and shouldn't be doing certain experiments without a very good rationale and, or more importantly, the appropriate containment. And that's an evolving and continually developing thing, and we need to keep that on one side. Invoking a phantom lab leak hypothesis for the origins of SARS-CoV-2 as a lever to bring in some form of restriction on virology research in a knee-jerk way is, one, not going to be very helpful, but two, is going to be particularly counterproductive. These natural viruses are not going away, and we do need to work on them and understand them to develop new vaccines and new therapeutics. And if we can't do that safely, and I stress safely, then we are going to be even worse off the next time something like this comes around.
No, absolutely, well said, Stuart. So I think I'll just finish there by saying the irony of working on something that's never actually been isolated, according to some, is not lost on us. Right, so with that, I think that I'll just thank David and Stuart so much for their insights into this, and I'll hand back over to Martin for the public questions. Thanks, guys.
Yeah, thank you so much, Steve and Aris, and thank you so much, David and Stuart, for what was really a fascinating discussion and for making it comprehensible to those of us who are not as well versed with the genomes of viruses as you are. So we move on to the Q&A session, and we've got a number of questions. First question is quite long, so I'm going to I think ask probably Helen to start off with this one. It's about testing, and maybe Steve might come in later. And this is from Liz Spencer. And Liz says that data show that the new variants are moving increasingly quickly from infection to symptomatic. And some of the current variants seem not to be detected on lateral flow tests until after symptoms have started. Nasal swabbing also seems to be the least accurate method of detection, but it's the method outlined in the instructions on the packs, and it's what most people are doing. What does the ONS or others such as Zoe data show us about asymptomatic positivity? It was always a big thing in the early days. Is it still worth spending money on tests for asymptomatic testing? So maybe Helen on the testing and the techniques, and Steve perhaps on the data, or maybe Duncan might want to come in as well.
Hi, I mean, I think there are clearly differences between nasal swabs and nasal and throat swabs in terms of how likely you are to get a positive result. And I think there've been lots and lots of examples on this, and it's really a question of where you're likely to pick up most of the virus. And so I think definitely people need to be doing throat swabs as well as nasal swabs. I think there are some issues about your likelihood of getting a positive result, even if you do have the virus. There was a study that was reported recently, which I think is where this question comes from, which I think 27% of people who had positive PCRs when they were asymptomatic had positive lateral flow tests. So the sort of test people are doing at home, if they didn't have any symptoms, they were likely, there was a high risk of them giving false negative results, i.e. being reassuring when actually you did have symptoms. Now, from where I sit in the GP surgery, I'm mostly seeing people who do have symptoms. And lots of people I see who say, well, I've done some tests, I've done a test, doctor, and I don't have COVID. It's not COVID. And I'm looking at them, I'm thinking, yeah, but you do have COVID, don't you? You've got all the symptoms of COVID and it really looks like COVID, and yeah, you've got COVID, but your test is negative. And that's really difficult for both me as a clinician. It's particularly difficult for patients because they don't know what to believe. But I do think certainly that it seems that the tests to which my patients have access at the moment are not 100% reliable. And I think somebody probably with better numbers than me can fill in some gaps there. So
Steve, I think this is one that you might be able to help us with.
Well, I can do, but I think I'll say something very quickly, and then if Stuart would like to comment, I think he's probably the best place actually, because he's very much into the testing side of things. I think it's important to emphasize that whenever you're getting negative tests on a lateral flow, it's either going to be a sampling problem, as Helen said, or it's going to be about thresholds, because those lateral flow tests just aren't as sensitive as the PCRs. And so as well as that, timing is a factor. And what we do know, and what we're pretty confident of, is that the virus has not mutated so it cannot be seen by these tests. It is always about the thresholds of detection. Remember, these tests don't detect the spike protein that does change a lot. It detects the inner shell of that virus particle, the nucleocapsid protein, which doesn't change as much, and it certainly doesn't change enough to stop the antibodies in those tests recognizing them. So it's always about thresholds, and what these tests are good for is showing if you are infectious. But I think it just also goes to show really what a mockery the current isolation rules are, basically, because we know that people are infected and shedding virus when they're not aware of it, and that's why we have this baseline prevalence that doesn't seem to go away. But I'll be quiet now and hand over to Stuart if he'd like to say something.
I'm not
sure.
sure.
We welcome your insight.
I'm not sure I've got much more to add to that, Steve. I mean,
right.
Yes, you're right. I mean, the original lateral flows, when it came to the earlier variants of concern, were very good at detecting when someone was infectious, if by that correlating with our ability to grow virus out of the swab sample as a proxy. But if they're becoming less and less sensitive in that regards, it's not because the epitope has changed in the nuclear protein. It's because the amount of virus that you need to set up the infection is that much lower, because the virus is more infectious and better spread. And so more investment into making these lateral flow tests more sensitive is what we need. But yeah, no one should trust a negative lateral flow test if they're coughing and have a fever.
Okay, that's a very helpful insight. So the next question is about immunity. So Danny, I'm looking to you on this one. And it's from Janice Plant, who says, I've read that unvaccinated children, which presumably refers to most kids age 11 and under in the UK, which in fact we saw from Duncan's figures, are being used as an immunity reservoir. In simple terms, can you please explain what children being used as an immunity reservoir means? And she then adds, I'm hoping the answer is not, so they keep infecting others in the community to increase the number of people with natural immunity. With SARS-CoV-2 being a novel disease and not knowing the long-term impacts, is it fair to the kids of today?
Yeah, so I think immunity reservoir isn't a concept that any immunologist would sign up to. You know, I think we haven't been fair to children at all during this pandemic, as in the UK and JCVI have been well behind the curve in terms of, well, both authorizing and then encouraging vaccination in school children. And that's really played quite a big part in fueling the latter stages of the pandemic in this country, and that kind of high baseline prevalence we've got, that we never really get it out of our schools. It's not a fair thing to do to children, and you know, any kind of residual notion people have from the beginning that this isn't a bad disease of children, not a common disease of children, you know, was out of the window a long time ago. We have an enormous population in this country of children with long COVID who've been devastated by it in terms of their, you know, exam entries, social life, education, you know, you name it. You know, I think we regard children as part of the same continuum as our adult population. We require them to be as well protected as possible.
I just wondered if you maybe like to say something about this term immunity debt that seems to have emerged in the last 12 months or so and is doing the rounds among some people.
Yeah, again, you know, I think there've been a lot of phrases, haven't there, that have been sort of intuitively rebadged in a sort of populist journalistic setting, as if they were part of the immunology medical textbook. And immunity debt has never been a chapter in that textbook. The idea that somehow our immune systems are designed to be frequently topped up by dangerous pathogens, and that's somehow a good thing, was never part of anything I learned, or I suspect anybody else on this call. You know, not really a thing.
And indeed, and of course, some of those who are referring to it are citing their own papers, which is an easy way of getting something into the into common usage. So I've now got a question which is about people who are immunosuppressed, and so I'm looking to Steve, I think, on this one. Although, of course, if anybody else wants to come in, please do raise their hands. And this is from Caroline Smith, and she asks, the current injected COVID-19 vaccines are potentially less effective for immunosuppressed or immunocompromised people. So do the new COVID-19 nasal vaccines have the same effectiveness for immunosuppressed or compromised people as they do for quote unquote healthy individuals? Or does the nasal vaccine still utilize the immune system in the same way as these injections? So I think you're maybe going to help us with a very simplified guide to some of the different forms of immunity there without getting into too many of the different IG and different letters.
Yeah, I mean, I'll do my best, but I really think probably this should have been Danny. But I think, yes, it depends, because immunodeficiencies are very diverse. They're very broad ranging. It depends what sort of immunodeficiency there is. Some of the medications in particular that people take for things like autoimmune diseases can certainly interfere with these immunizations being as effective as they would be in other people. But this is always on a scale. It's always on a spectrum. So it's really hard to say that this group of people will or won't respond to a certain type of vaccine. Certainly, you're a bit behind in starting the race if you're taking immunosuppressive medicines, if you have a condition that dampens your immune system in certain ways or others. But it's really complicated, and I often think it's really difficult to put people in these boxes, as it were. And what we should really be doing is trusting our clinicians the specialists that are treating these people to understand whether or not they might need better protection from the vaccines. I'm afraid, I think it's probably true that if you don't respond well to an injected vaccine, you probably won't respond very well to a nasal vaccine either. But again, it really is nuanced based on the sort of medication or condition that you're suffering from, I'm afraid.
Well, I didn't ask Danny simply because I'm about to ask him the next question, but Danny, do you want to add anything to that?
I couldn't add much to that. I mean, I think Steve is right. You know, you although the immune system is really complicated, you can just view it as a kind of the weaponry for battle that has thousands of different kinds of weapons in it, and one kind of patient might be lacking some weapons and another some others. But essentially, the new vaccines we're talking about, the nasal ones, are similar as far as how they would be dealt with by that weaponry. So if you can't respond via one route, you possibly can't respond via the other either.
Okay, thanks. So we now have a question from Tim Kirby, and again, Danny, this is about immunity. And Tim is interested in antibody testing, and says that the earlier Roche test had an upper bound of 2,500 units per mil, which he says was a bit useless after a few vaccines, but companies like Monitor My Health seem now to go up to the 25,000 range. Are there any studies into what is a good antibody response after vaccination and what sort of levels protect from infection and serious disease?
So I might pass to some of the others in a moment, but that sounds like a very simple question. But, 2.5, 3 years into the pandemic, it's really, really not. Because that initial antibody testing that we're talking about was about binding antibodies to the ancestral Wuhan RBD sequence. So in the early days, it had absolute meaning in terms of how it relates to how likely you are to be protected. 2.5, 3 years in the land of Omicron, we've kind of lost the connectivity between what's a good number and what's protection. Which is my way of sort of ducking out of giving the question an absolute answer for a value, but I think we've lost that. I mean, that sort of literal connectivity.
So what you're basically saying is that it's not just a matter of the quantity of antibodies, but the fit in terms of the variants that are circulating. Great, thank you very much indeed. And our fifth question, which is on, would have been actually for our two members who have unfortunately had to leave a little bit early, and that's Trish and Steve Riker. But it is from Maston Lawrence, and it asks, so I might look to Susan for this perhaps, or maybe Zubaida. How would you advise we approach COVID-19 safety conversations in the workplace? So this obviously relates to the work on the pledge that Steve Riker has been doing, and encourage our colleagues to engage with and implement evidence-based mitigations. My employer has pretty decent official guidance in place, mask wearing, ventilation, staying at home, etc. But no one follows it, not even those in leadership positions with a duty to be role models of best practice. Any practical advice or personal experience on successfully engaging people in the workplace would be really interesting, especially in larger employers, places of education. So I'd mention maybe Susan, but I'm also conscious that Aris has an interest in this too.
Yeah, I'm happy to start off with this. I think the first thing is to think about what groups are already there and talking to each other in workplaces. Are there trade union branches? Are there informal social groups? Think about all the places people are discussing things. And the first thing really is to ensure that people have the knowledge, that they understand what the benefits would be for them, their employer, their job in the long run, if they are to follow those kind of guidelines and therefore keep transmission and infection rates down. So that's the first thing. But we know that having knowledge is often not sufficient for people to change their behaviour in line with that knowledge. So one also needs to think about how to motivate people, how to make it worthwhile, how to persuade people. And there are many different ways of doing this. One important thing is to get a group of people to begin adopting that behaviour. And I mean, just a small example of that, I was on a plane a couple of weeks ago and I was wearing a mask, as I do in all public transport. And the woman beside me turned around to me and said, would you like me to wear a mask? And I said to her, only if you'd like to. And she put on her mask immediately and kept it on for the whole flight. So I think even if it's just a few people adopting the behaviour, other people are likely to follow. But some people will have more leadership roles than others. So the kind of people who have influence, the more that they will do it, the more others will follow too. And there are many other ways of enabling and supporting those kinds of behaviours. But I'd say the first thing is meet with other people, have those discussions, and also think about who there is in different positions of influence and even power in the organisation that can help support it, but very much think about how to encourage, persuade and support in many different ways.
So Aris, I know that you've been thinking quite a bit about this.
Yeah, I mean, I think the behavioural points that Susan raised are really important, and probably, you know, our individual safety and the behavior of the small groups around us, probably the things we can affect most effectively. Ultimately, the structural things that will reduce everybody's risk, like ventilation, like safe workplaces, and all that sort of thing, are things that have not, unfortunately, permeated into many workplaces, right? Like, you know, the idea of keeping windows open seems to now have gone out the window with people saying, well, you know, I'm going to keep the energy bills down and shut all the windows in a busy lecture theatre with 100 people. But trying to affect those structural changes, you know, ensuring mechanical ventilation in large unventilated spaces are going to matter in the long run. And I do hope that through discussion, through trade union pressure, through a better understanding, that we will bring those structural changes into our lives going forwards.
Great. Well, thank you very much indeed. Well, it's now just after past, so that's all the time that we have today. So I'd like to thank in particular the guests who joined us because of the really very valuable contributions and the clarity of their explanation. And thanks also to all of the members of Independent Sage and to the members of the public who sent us the questions, and to you for your continued support. Well, we'll be back next week at the same time in the same place. Until then, keep safe. Thank you.
Cheers, everyone.